I don't know if you know it, but I have the huge privilege to spend one day in the week podcasting with a couple of friends of mine, amongst others Hans. Hans, are you here? Are you in the audience? Yeah, over there. The podcast is called Working Draft. You find great stickers outside, and you can listen to it every week. And there are some special episodes when you do a podcast. Usually it's a conversation, and we are chatting. But there's those special episodes where you, as a podcast host, go into listening mode. And such an episode happened with Marvin when we were talking about Preact.js, and then he told us all those little tricks he did to make Preact what it is. And I thought, oh, this might be a great conference talk. So I invited Marvin, and Marvin said yes, and here he is. Give it up for Marvin.
All right, let me just turn on my laptop again. Just went into sleeping mode. So we are going to talk about the art of deleting code. Like if you've seen the schedule which is printed on the backside, you've seen the art of removing code, but I found like deleting is an even stronger word, so I chose that. Before we begin, a little bit about myself. My name is Marvin Hagemeister. Funny thing is, it's a good name to test like layouts because my name is too long. So even Twitter, just the last two characters wouldn't fit into the Twitter handle limit, so there you go. And sorry also to the organizers for breaking the website layout on mobile, because my name just shoots off the window, sorry. So I'm a web developer for about 8 years now, and I mostly work in enterprise software. I'm currently employed at Awesome Software, and where I'm a consultant. And what we do is we go into banks like German Bank, Deutsche Bank, or car manufacturers, insurance industries, and kind of help them with their legacy software and make it running again. And so the typical request is like, our current project is stuck. It costs too much money to add new features. What can you do about it? Can you help us? And that's where we come in. And this fits greatly with one of my hobbies, which is to work on Preact. We'll talk about it a little bit later, where I'm one of the main developers there. We just released a new version, and I wrote like a huge portion of it. And Preact being Preact is, you cannot say Preact without talking about simplicity, because we fucking love simplicity. We're kind of obsessed with making things easier, which naturally moves into my day job, and it's a lot of fun. So Preact, what is it? It's a framework. It's yet another framework. It's a little bit older. It's the basis of Google AMP. As you may have heard the news, it's used in Smashing Magazine. It's used in DevTO. It's used at bodybuilding.com and a bunch of other companies. Like we have a big list on our website. And the main reason people use Preact is because it's tiny. Like we heard all these great talks by Robert about performance optimization and previous talks, and like we really take it seriously coming from a JavaScript background. And the thing about Preact is like one would think like, okay, you must have cut corners, you must have like left some important features out or anything. And the honest truth is no, we don't. We have the full feature set, and we even have an API that is pretty similar to React. Like, in fact, we have a little add-on. This is like a compatibility layer between React and Preact. And when you're using that, which I think it weighs like 2.1 kilobyte currently, if you put it together with a 3.0 framework of Preact, you can actually use most of the components that are out there, and they were specifically written for React. Sorry. So you can just use a Webpack alias React to Preact compat, which is our compatibility add-on, and like I guess like 90% of web apps continue to work. This means like MobX, Redux, RxJS. We can use your official React bindings with Preact, which is pretty great, and it makes switching easier. So this is a typical Preact component. As you may see, it looks a lot of similarities to React, and in fact, the only difference is the import statements. Like for us, hooks is a separate add-on. We're currently working to bring it into core, but more about that later. So the special thing, 3 kilobyte. Like when we were talking at the Working Draft podcast, like nobody could believe it's like it can't be right. Like you must do some black magic or anything. And the honest truth is we don't. We don't do anything like you couldn't do. But what we do is we have a really, really strong focus on simplicity and not just on a code level, but also like from an architecture point of view, like how is our system composed? And for that, it's crucial to know the whole system. We just released a major version. It was, I think, like 3 or 4 weeks ago by now, where we added a lot of features like fragments, component catch, create context API, and lots of other things. And the funny thing about this release is not that we have now all these great features still in the same 3 kilobyte range, but the size difference. So the previous version was Preact 8. It sat around 3.6 kilobytes. This is the minified and gzip size. So if you put it through Terser or any other minifier and ship it via gzip compression, this is the final size you would get with the previous version. And with the new version, we're exactly at the same size, which is ridiculous if you think about it, because we added tons of new features, as you have seen in the previous slides, and even a lot more features that it just wouldn't fit onto this slide, but we're still at the same size, so what happened here? And you may notice also the difference in version numbers, and the honest truth is we always planned to make a 9 version in between 8 and 10, but the thing is, we wanted it to be just the breaking changes that were internally, no new features, kind of sort of like a migration release, so upgrading would be easier for our enterprise customers and sponsors. But the thing is, like with the open source, we pushed our first alpha of Preact 10, and everybody immediately jumped on it. And over time, we refined the upgrade process so much that nobody saw a need to do a 9 version. So we kind of pulled an apple here and skipped the 9, and jumped straight to the famous X. So yeah, here we are. Here is Preact X. And at this talk, we're going to unveil what it takes to make a library this small, because it's different. And this was kind of the first reaction. If you don't know Tom Dell, he's one of the authors of the Ember framework. And funny story, we framework authors, we love each other's work, so there's no competition there. And we usually have like hangout calls or private messages with each other. So we kind of love every framework because they all push the web forward. But this is like, we are arguably one of the smallest and most feature-rich frameworks out there. And so how does it all work? And most important, how do we get so small despite adding new features? If you look back and pull out statistics of all our past releases, you would see that we have never crossed the 4 kilobyte limit. We always had a 3 in front of our total size, even though we kept adding features and kept rewriting Preact and whatever, we always stay at 3 point something kilobytes. So most important is simplicity. And it took me a while to figure this one out in my own career. First, when I was starting out, I was always wondering, like, why are these senior people getting paid so much that they write such simple code? They could write complex code, but they're writing so simple code. Like, I could write it. Why are they getting paid so much? And the honest truth is, it took me a while to figure out, like, they're getting paid so much because they can take a complex problem and make it simple and make the solution so obvious that anybody, someone like me, could understand it. And since then, I've been pretty obsessed with simplicity because it helps you just streamline your workflow and be more efficient. Like in my teams, when I join a new consulting company and help them out in a project, I'm typically the guy that bashes out features the quickest. And this is mainly due to like strong simplicity because I don't over-engineer solutions. And experience has taught me to kind of make the right decision on architecture. One important thing, I'm coming from the enterprise background, as I said before, so there's a lot of craft, there's a lot of legacy code, and you typically find people that have been working at these companies for 10, 20 or longer years, and they say like, I don't want to change anything. Like, I've done this for God knows how long, and it's simple for me. But the honest truth is, for everybody else, it's a nightmare. Like, you may have a process in enterprise where you need to do this, and then you need to click on this button and that button and what else, and blah, 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 yada, yada. And the thing is, it's not simple. It's familiar to that person, that's why it appears simple to him, but it's actually not simple. So my motto throughout programming is that familiar things can be complex things in disguise. So do not confuse the two. Simple is not familiar. And for Preact, like most of the size savings, they actually don't come from any black magic we pull off. Like we call it code golfing. Code golfing is a description for I would say, yeah, I'm not sure it's officially a sport, but it's like, yeah, it's like you have like a problem and you need to find a solution with the least characters possible, with the best gzip compression or anything. Basically finding the shortest answer possible. And this means that you have to know how the language works. You need to know all of the edge cases, which you can maybe abuse. There's a lot of cool stuff you can do then. We could talk about this all day. But the honest truth is code golfing gives you like nothing. It gives you a little bit, and we go the extra mile to do it and to keep our size small. But the main benefits is architecture. And I hope that this is the point that you bring home. Think about what your code is doing, where it is doing, and above all, make sure that you know the whole system and that you're not optimizing just your own silo. And it may make code easier for you, but it may introduce complexity for the whole system, which is pretty bad. This is called local optimization. And also, when you have like a good architecture, it usually leads to less repeated code. DRI standing for do not repeat yourself. Because like a better architecture can help you shake out all the edge cases. It can make the whole system simpler. So this is very important. It's just one of the main rules that we do. And in fact, our size savings or our total size is mainly based on this key inside. So really, really be careful. So what happened? How did we manage to make Preact 10 so small and even the same size as Preact 8? And to understand that, we have to go to Preact 8 into the main architecture. Like Preact 8 is similar to React or some sorts, to some extent of Vue. It's similar in that they compare the changes that are in the DOM to an in-memory structure, which is often referred to as virtual nodes or virtual DOM tree or whatever. We call it vnodes for virtual DOM node. So you basically have like, on the right side is if you would log out a simple console log of a standard diff element, and on the left side is our internal structure. And you can see already here that there's a mismatch. You can see some properties are the same, but then there's a difference in how attributes, for example, are stored. Like the DOM is pretty old, so it has these special objects like name, node map, whatever that is, HTML collection. These are not native JavaScript objects, so you have to introduce in your code more if statements if you're going to compare this. Like you can easily compare the node name. It's easy. It's the same string. So he's like, okay, he's rendering a diff. But now if you're wanting to add the foo class to it, you have to check like, all right, I have to compare the left structure with the right structure, which are both different, somewhat similar, but still different. This means that you have to introduce more if statements into your code. And if statements are pretty bad. And we're going to see why they're bad. So this is my visual representation. I tried to use emojis, but then Google Slide screw with me. So here are like apples, the red dots, and oranges, the orange dots. So I had to use my creativity here. But I hope the point is still clear that you're trying to compare two different view trees. And this is even more important when you think about components, because like, how should you compare components with a DOM? There are no components. There are sort of web components, but despite the same name, there are a different abstraction. You cannot map them one-to-one. So what we did in Preact 8 to work around that was to, like we had on each DOM node underdashed component property, and if you would have a higher order component, that component would have another underscore component property, and so on and so forth. So we had like two ways of traversing the tree. The first way was like standard DOM traversal. You can just walk the children down, which is also pretty fast, by the way. But when you come to component, we had to take a different code path. We had to walk these component properties downwards. And this is another if case, another where we introduce complexity in our code base, and we wanted to get rid of that. So it's crap. Yeah, it wasn't cool. And to be honest with you, I don't know how Preact 8 could have ever worked. But it somehow did, so yeah, there's that. But we had a good opportunity with Preact 10. We basically rewrote Preact from scratch because the base assumption of the mapping from vnode to DOM changed. So we had a good time to reflect on our learnings we did and kind of redo our code. So this is standard code that you'd find in Preact 8. You do not have to understand it fully, no worries. It's just more a visual representation of how much we can save. So in this case, we're trying if we have a text node here, and we're trying, all right, he just wants to update existing text. So in order to know that the DOM node is a text, we have to check against the DOM text element. And the quickest way and the smallest way for us back then to do it was not instance of text, but to just check if there's a property split text on it. TypeScript will scream at you, no doubt, but in JavaScript this is perfectly fine. So yeah, we kind of did that, and then you see it's a mouthful. So in the other case, when the node isn't a text node, we need to create one, add it to the DOM, and we need to check if there's a parent node, otherwise it's a no-op operation. And also this is a little thing, we'll talk about it later, it's basically an optimization that we did that is typically found in game engines, but it turns out it wasn't that great for us, so we killed it later on. So Preact 10, we don't compare apples to oranges anymore, we compare the same data structure. This has a little bit of memory overhead because now we have not one copy in memory, but two times the view, but it makes everything simpler. And the funny thing is, the memory overhead isn't that bad. So it's like even like you get many benefits for free. You get performance for free. It's much faster. You get smaller code size. So you just win on every front, and which was one of the key learnings we had. If you look at these two, it's easy. Like if this would have been a task for you to compare these two objects, it's pretty easy. Just compare the type. Just compare the props. There's a one-to-one relationship between the two, so that's fairly easy to do. Yeah, and just a visit, like we compare apples with apples now, which is great. And it also solves another problem, and this is the problem of component comparison, because now we can compare components. We do not have to do any magic fuckery with with the underdash component trees or go into a different route of traversal or anything. We can just use the same way of traversing for both, comparing the old and the new. And this is true for every new component type we introduce, like suspense or fragments or whatever may come that is a built-in component. We can just reuse the same code, which is a huge, huge saving. And also much easier to reason about. So same code as before. We're checking if you want to rendering a text node. In our case, we detect text node when the vnode type is null, which is easy, fair enough. So if there's no DOM, we just create it, boom, done. If there is an existing DOM, which is implied by the else statement, we just check, hey, has the text changed? And if it has changed, we can just swap out the data and we're done, which is pretty cool. Because once you put them side by side, you can see there's a lot of savings coming from this. Like the right side, the new version, is a lot shorter than the left one, although both are doing the same thing. So the best decision you can make if you want to make be a quick worker, if you want to be able to move fast and efficiently and even remain a maintainable code base throughout all this time, is to think about your architecture. Keep it really simple. So this is one of the key takeaways that we had when we were writing Preact X, and I think this image speaks for themselves. So learning code branches are evil. Like you can take a picture of the slide, tweet it without context, it always works. Because they are evil. As soon as you introduce a new code branch, a new if statement or whatever in your code, you need to check that branch with unit tests. You need to account for it in QA. You need to account for it not to introduce your bugs. So everything kind of just doubles, which is pretty bad if you're working on a big project where there's a lot of pressure to deliver it on time. So the best way you can counter that is just do less if statements. So one way that you can do that is by normalizing data structures, not just like we saw it previously by comparing the same data structure and not different data structures. And another way where we do that is components. Like in React, there are function components where you just have a function that returns a virtual DOM node, or you can have class-based components. And the funny thing is, internally in React, we do not differentiate the two. We have only class components. Like, so the first thing that we do once we see, all right, he is using a functional component, we turn it into a class. And it's this code that does that. It's not possible in many other programming languages, but JavaScript being JavaScript, it's possible. It's also slightly slower than just having a fast pass for functions, but we make up for that slowness by having a pretty highly optimized render function. So in the end, it evens out, and we can get away with normalization. Because doing so, like, you can just reuse the same code that checks for if there's a class lifecycle there or whatever we need to do. We can just use the same functions for different things, which is pretty cool. So as you may see, there's a big emphasis on reusing code, and we kind of have mastered that. So really important. And here's the part where you check, oh, this is a class component. You can easily check if there's a prototype object. Like prototype, you may not have heard it if you've been new to the industry. It was pretty popular to deal with prototypes back in the day manually. Right now with ES6 classes, it's less of a knowledge thing, but it's still good to know if you know all the ends of your language you're using. And if it was a function component, we just create a dummy class component and assign the render function. So it all works out. This is the way to normalize it. So funny thing is, in React, it's 3 kilobyte big, and we still had technical debt. Like, which is ridiculous if you think about it. Like, how can you have technical debt in 3 kilobytes? It makes no sense. But we did have technical debt. And one of these, I guess it's like we touched a little bit on it earlier. Like, one of the things that was really biting us was the component recycler. It's an optimization that is frequently found in game engines where you pre-allocate all memory, and instead of creating new objects, you just take one object from the pool and reset all properties and override it with the new ones. This has the benefit that you're not creating new allocations each time you're needing a new object. This is especially true if you think about virtual DOM, because you're always creating these new trees, all these short-lived little objects which put a lot of pressure on the garbage collector. But the thing is, we did it with DOM nodes, and yeah, it didn't work. Because the DOM, it only works if you have something which is in your control, 100% in your control. And DOM nodes aren't, because it's easy to have an extension that adds a class to manually have some user code which just inserts another node or whatever. And worst of all, input elements or any kind of form control has state. So if you're not careful with it, you may leak input data. Like if you recycle an input and use it for another input at another part of your website, it may have the old input value from the previous input. And all this weird, it was just basically leaking state all over the place, and it was the first thing we wanted to get rid of, simply because of the number of bugs we had. It may have made sense back in the day, but we always checked performance against the most popular sites that we know, and the honest truth is we optimized the rest of our code so aggressively that we didn't draw any benefits from having this optimization. So we just could let it go, which is great. And another thing is, adjacent text node, it's always a head scratcher for sure. What we did, we tried to avoid DOM operations when you're creating a text. Like imagine like saying like, hello, my name is, and then blank, you have a piece where you fill something in. And if you're looking at the DOM that it would create, it would be 2 text nodes. And back then we thought we could be smart, and we could merge the text before we create a text node, so that we only need to create 1 text node. But the thing is, it was pretty bad, because now you need to prove that the next element is a text node. Otherwise, you cannot do this optimization. And this is even worsened for if you take fragments into account, where the whole point of fragments is to be transparent through the DOM. So you always need to crawl over fragments to check if the next node of that node is a text node, and it could potentially be like, you could potentially traverse the tree down to theoretically infinity, but not really infinity, like really deep down and just do a lot of work which is unnecessary, and which would likely be slower than just creating 2 text nodes. So we canned it and we just create 2 text nodes in this example, which is like, it was one of the learnings where an optimization backfired. And we're happy to see it go and also made everything simpler. So all in all, pre-Act 10, the funny thing is you see like a hill and where it went downhill. This is where we started pre-Act 10. We had it a bit earlier, but it's easier to visualize. And the funny thing is, without new features, we were below 3 kilobytes. For the longest time, we were, I think, at 2.2 or 2.4 kilobytes. So it's possible to go even lower. It's possible to go below the 3 kilobyte threshold. But there are, of course, history is a better teacher, and we later in our development cycle we thought, oh God, we forgot about hydration. So yeah, we need to edit that in. And hydration is kind of like when you're doing a server-side rendered page and you want to make it interactive on the client. We have a fast pass for that where you just call hydrate on the component, and it will just attach event listeners and won't diff anything, so that when you click on a button that it actually does something. And it takes a little bit of code, so yeah, there's one climb there. And the other big climb that we had is we didn't originally plan to add it, but we had headroom for it, so I guess why not? We added the new context API from Preact, which is basically a simple pops up component where you can publish something higher up in the tree and trigger updates down below in the tree. And the problem with the previous context API was that it could theoretically block updates, which is not what you want. So we saw it as important enough to have in Preact. So we lost some bytes there, but I guess it's fine. So yeah, we're coming a little bit to the end of my talk now. Code golf, yeah, it doesn't give you much, but it's fun. So like we always have these PR, I think I don't have a screenshot here, but whenever somebody does a PR, it says like, okay, this adds, I don't know, 10, 20 bytes. Like, make note here, we don't talk about megabytes or kilobytes. Our PRs are measured in bytes. So like, maybe 10 or 20, and everybody jumps in like from thinking like, oh, maybe I can do it smaller. Like you see, when he wakes up, like you know the time zones of the other team members, and you say, oh, he's waking up, and he's just checking out this pair, and you see him frankly typing in Slack. So maybe he has an idea to make it shorter. And the funny thing is we often find shorter things, so we just nudge our heads against it. And yeah, to give you an idea what this means, here's one optimization that we did is like, you see it's a simple math function. We're not using math in our project, but it's a good way to illustrate. So we should just take the square of something. And you can store the property access in a variable. And if you repeat this call a lot, it compresses better for gzip. Because a dot and a property compresses pretty badly because you have to preserve the dot and the property and the thing that was before that. So you can skip all that by just having a single character, which compresses a lot better. So we have like in our code, which just destroys components, we just reassign the character all the time. It gets us like 10 bytes, which is nice. So yeah, like we care about these 10 bytes, make no mistake. But this is probably not an optimization you should do in your code. Like, take no mistake, it should only happen in libraries. But it's a fun thing, so yeah, you can save some bytes. And the next thing, yeah, our create-ref implementation. I'm particularly proud of it because it's nothing, it's just an object. Because the thing is, if you know React, like refs are used to get a reference to the underlying DOM node of a component. And the way that it is done is like you have an object where there's a .current property. And if you would have been correctly type safe, you would have a property current which points to null. And as soon as the component is mounted and is visible, you would assign the DOM node to it. But we know our users pretty well because many users just write if ref.current, and do not explicitly check if it is null. So by not having this property current, we save a few bytes. And if you know, like, if you just do the if check, it would cast to a Boolean automatically, even if it is undefined or null. So yeah, it works out for us, which is great. Also, I'm not sure, like, shoot, I don't have it. But there's also another way we're using, like, in Preact you can render a component without defining a render function. And we saw, like, oh my god, how should we do that? And we start thinking, wait a second. We have fragments, and fragments are basically a render function. So the default render function of the base component class is a fragment. We can just reuse that because a fragment just returns the children directly, so it's basically a no-op. And yeah, we make use of that. So in summary, the key takeaways I hope that you will take home with you is know your code. You cannot optimize what you don't know, so you really have to know your code to be able to optimize it and make it simpler. Normalize all the things, like think of it like whenever a data structure like user input, API, or whatever enters your system, it has to be normalized as soon as possible so that your code stays simple and can work with the same data structures. If you delay it to be later and do this normalization later, you always run into problems, so do it as early as possible. And most importantly, simple is not familiar. This is I think one thing I encounter on a daily basis working in banks and stuff. So make no mistake, don't confuse the two. And above all, avoid local optimizations. Like, do not optimize your system without knowing the effects your system has, or your silo or your piece of the system has on the whole system. So do not try that. Or if you do any optimization, check with your neighbors. This is especially true if you're having a microservice architecture. Check if it makes the whole system easier or if it introduces complexity. So yeah, this is my talk. I hope you had fun. I hope you learned something here, and you can check me out on Twitter. Again, I'm sorry for the last 2 characters that are cut off, but yeah, hope you enjoyed it. Thank you.
Thank you very much, Marvin.